Very quick, very easy section. They're going to give us a bunch of limits. Sometimes it's a one-sided limit like this. Sometimes it'll be a two-sided limit like this. And just the answers for a lot of these are going to be infinity just because the answer is infinite limits there. So do your normal algebraic techniques. And if you can't do the algebraic techniques, a lot of these in this section are going to be XY charts. So for example, limit as x approaches 0 from the left. That means I only concern myself with the left-hand side. So I'm talking like, sorry, I'm talking the negative 0.1, the negative 0.01, and negative 0.001. And this is, you're going to see why I had you do this progression here. So when you take these numbers, plug those in place for x, what you're going to get a negative 9, then a negative 99, and then negative 999. So when you show this progression like that, and then you get like a huge jump like that, that's when we could say that this is going to approach negative infinity. There's my work, there's my justification. See, if you just start down here, then you don't know if it's going to like negative 1,000 or something like that. But when you show that progression, if it just jumps from like 10 to 80, that's not quite big enough. But if it goes like 10 to 20 to 100 or something, you know, and it starts jumping pretty quickly like that, that's going to be infinity or negative infinity. So you got a lot of easy XY charts in there. And then the other part of the assignment is finding vertical asymptotes. And you already know this from your pre-cal days. A vertical asymptote is simply where the denominator is equal to 0 and it doesn't cancel with the numerator. So if I give you something like this, then obviously we know the vertical asymptote is that x equals -4. If I give you something like this, if I just say find the vertical asymptote only, the only vertical asymptote is that x equals -4 because the x equals 3 is a point of discontinuity because that original denominator is equal to 0 there. But because that cancels out, remember that's a hole in the graph at x equals 3 and it's a removable discontinuity right there. So it just get you some practice, find the asymptotes again. That'll be important for us in chapter 3, and then just doing limits some more and doing some XY charts and getting infinity or different answers for that. Thank you.